Swayam Prabha. Digital India. Educated India.
Good day everyone and welcome to these lectures on physico-chemical processes for wastewater treatment. So, we have come to the end of these water treatment processes and we have studied a lot of unit operations or processes or methods which are used for water or wastewater treatment, and we started with the flow equalization basin, and then we started studying the aeration. Thereafter we studied coagulation, flocculation and settling, and in addition we studied the various adsorption and ion exchange processes which are used for treatment of water. Thereafter we studied the membrane separation processes including microfiltration, ultrafiltration, nanofiltration and reverse osmosis for water treatment. And in the previous sections we studied a lot of advanced oxidation processes for destruction or mineralization of various organic and other type of pollutants present in the water, which are very difficult to remove otherwise. Now, this is the last section that we are going to continue now, which is called as disinfection. So, in the disinfection we use techniques which are similar to advanced oxidation processes like UV oxidation, and then also we can use lot of chemicals for removing some of the most of the pathogens which are present in the water, and these pathogens may be bacteria, virus, cyst or any other types of worms or larvae. So, if these pathogens are present, so they will cause lot of diseases to us. So, we have already studied various types of water related diseases earlier, and if these pathogens are present in the water and we use the water for drinking in particular, then we may get infected and that may cause a lot of problem. So, it is very necessary to remove these pathogens before we use the water for drinking. So, there are number of techniques which are used for disinfection. So, in these lectures we are going to study regarding these techniques. Generally there are many chlorine related chemicals which are used for disinfection. In addition, UV radiation etc. can be used, and there are some minor other chemicals also which are used for disinfection. So, we will try to learn all these chemicals, their chemistry, how it works along with the water, so as to remove these pathogens or mineralize these pathogens. So, and what are the doses that is required for disinfecting various pathogens. So, all these details will continue in the disinfection lectures that will start from today. So, starting, disinfection is used in water treatment to reduce pathogens to an acceptable level. So, this is very important, but there is a difference. We always, whenever the term disinfection comes into our mind, so there is a some confusion with respect to sterilization which is used in the biochemical engineering and other places. So, sterilization and disinfection is little different. In the sterilization we want to destruct all the living organisms, whereas in disinfection we reduce them to within an acceptable levels. So, drinking water does not need to be sterilized to be safe for drinking. We have to only see that all the pathogens, we may be human enteric pathogens, which are of concern in drinking water, that is bacteria, viruses and cyst, ambic cyst, they are reduced to an acceptable level. So, this is the main objective of disinfection and how it works, and disinfection is capable of destroying all these viruses. We need not destroy those, but those microorganisms which may be good for our body or otherwise. So, we try to see that we are able to destruct the pathogens within an acceptable limit, and it is different than sterilization. Now, going further, there are different types of agents which are used for disinfecting the water. So, most common agents are related to chlorine. So, chlorine, free chlorine, combined chlorine or chlorine oxide, they are very commonly used for removing pathogens or reducing the pathogens to an acceptable limit. In addition, ozone can be used and ultraviolet irradiation can also be used for destructing these pathogens in the drinking water. Going further, other disinfectants which are used for different situations for in various conditions, they are given here. So, ultraviolet radiation already we have discussed. So, they may be used for public supplies, railway, refreshment vehicles and restaurants, etc. And with COVID, the use of ultraviolet radiation for virus removal, its usage has increased way beyond the water also. So, anything which is any type of pathogen or virus which is present on the any of the surfaces, so they are being removed using ultraviolet radiation. So, it has become a well known thing nowadays, and it is very similar to like we have studied photo oxidation. So, this is very similar to that. There are certain difference may be there with respect to the ultraviolet wavelength that we are using, but this is similar to photo oxidation itself. So, this is there. Now, silver for in-house water sterilization. So, many times it is used. So, silver is considered to be highly good in removing or disinfecting the surfaces and water as well. So, this can be used. Iodine has also been used temporarily for small scale use in emergency cases. So, for emergency cases and where there has been a tremendous increase in virus and bacteria in the water. So, sometimes it may be used. Potassium permanganate for pre-disinfection of the water before other treatment strategies can be used. So, this is also possible to use potassium permanganate, and also potassium permanganate is used for iron and manganese removal. So, it works for pathogens, iron and manganese removal, all three if potassium permanganate is used. Boiling of domestic drinking water supply is very common, and it can be used as a disinfection method for using the water for drinking purposes. So, these are the other techniques which are possible for use and they are available for disinfection. Now, the organisms in water which are very necessary to be removed via disinfection, they include like bacteria, various types of bacterial spores, viruses, cysts and protozoa, and the low forms of animal lives such as worms or larvae. So, all these things we always target them to be removed from the water, so that we can use the water for drinking, and they may be removed by using the various chemicals which we have discussed, or ultraviolet radiation or some other techniques. So, we have to employ these. Now, resistance of these organisms towards disinfection varies according to different types of situations. So, in the water we have to see that which type or subtype of organism is present. So, depending, and also whether it is bacteria or virus. So, depending upon that, the the dose of the chemicals, or in the case of radiation the intensity of radiation may vary. Also the number of organisms. So, the type subtype of organism present and the number of organism present, they all change the dose response curve. So, in this way the amount of chemical to be used or the wavelength of the chemical to be used and its intensity changes. The physical and chemical characteristics of the water. So, in the water in which these pathogens are present, the characteristics of the water like temperature, amount of other solids, suspended solids present, organic matter present and the pH. So, all these parameters affect the this amount of disinfection that will occur at a particular condition. Also it will vary depending upon the type of disinfectant that we are going to use and its chemistry with the water. So, that is very important, and that chemistry will be highly pH dependent and also dependent upon the different types of organic material and suspended solids that are present inside the water. So, this is there. Now, the amount of disinfectant which is applied and the time period for which this has to be applied, that will also depend upon the all these factors. So, depending upon these factors, the amount of disinfectant, the type of disinfectant and the time period for which it is applied, that will vary. So, this is what we have to learn and this is how it is applied in the actual field. Now, chlorine and their various compounds are one of the most widely used disinfectant. To everywhere most commonly chlorine and their various compounds are used. Now, why they are used? So, there are certain reasons for their very wide use, and these reasons are that these type of compounds are they are easy to use and they have very good mineralization efficiency with respect to pathogens. So, they are able to remove the pathogens and destruct the pathogens maximum possible level, and this is possible because the chlorine is like a halogen compound and it has only one electron requirement towards fulfilling its valency. Now, what happens is that, so that is the chlorine or any type of halogen compounds are one of the most reactive elements. So, thus the chlorine and related compounds are also highly reactive elements. So, thus they are, if they are present or added in the water, they will react or they will react with the body parts of the pathogens and thus they will destruct them. So, and so this is one of the reason, because of the high reactivity, high oxidation potential of these species, they are able to destruct the pathogens. Now, these chlorines and their compounds are cost effective and they are easily available as well. So, this is another reason for their wider use. Now, ease of application is also there because they are available in various forms. So, we can use them in various forms. They are highly soluble in the water and they produce desirable residual chlorine to ensure that the bacteriological purity is there in the distribution network after the treatment is done. And they are non-coloring type and they are severe, they cause odor removal as well. So, they are able to destruct not only pathogens, they are able to destruct other types of organic compounds and other things present in the water. So, that is why they are very commonly used for disinfection. Now, chlorine has some disadvantage also and which should be kept in mind while using them. What are the disadvantages? That since chlorine is highly reactive, so it will react, it can react if present in the water beyond a certain value to the human body parts as well. So, thus it can harm the human beings also if present in a very high concentration in the water. So, we have to be very cautious with respect to usage of chlorine because they will be used for destructing the pathogens, but if more amount of chlorine is used. So, it will not be used up for disinfection and it will be remaining in the water. So, and if you are using that water, so that chlorine will affect us. So, this is the problem. Now, there are, in addition, the chlorine may form chlorine gas, which is toxic and which requires careful handling as well. So, this is another reason. Some of the limits which are given here with respect to chlorine, and it is shown that at 1 milligram per liter the chlorine is like harmless in air if we use breathe it for 8 hours, but at 3.5 milligram per liter some odor will be, we can perceive some odor if it is there. At 15 milligram per liter it will cause throat irritation. After throat irritation we can have cough problems if it is present at 30 milligram per liter, and if the short period exposure to 40 milligram per liter or beyond is there, then it will start causing problem to us and it will be dangerous. And at around 1000 milligram per liter, that means 1 gram per liter, it can be fatal also. So, human beings can die because of the presence of chlorine. So, this is there. So, that is why we have to be cautious with using the chlorine, but chlorine is one of the most commonly used disinfectant. Now, going further we will try to learn the disinfection chemistry with respect to different chlorine compounds, and some of the disinfection chemistry. Understanding this chemistry is very important, and with respect to that which type of chlorine species is available at what pH inside the water. So, through that we can come to know whether the pathogens will get removed or not. So, this chemistry will tell you little bit idea regarding this. So, free chlorine is one of the most commonly used disinfecting chemicals, and the term chlorination is used sometimes very commonly with disinfection. So, in the field people will say sometimes chlorination. So, chlorination means disinfection. So, this is there. Now, elemental chlorine, chlorine may be used as elemental chlorine, then sodium hypochlorite, which is very common, okay, and it is also known as bleaching agent. So, this is also used for disinfection. Then calcium hypochlorite, okay, also known as HTH or high test hypochlorite. So, hypo, common word is, if you go into the field they will tell, okay, we are using hypo. Sometimes the labor or the person who is using may not know it is sodium hypochlorite or calcium hypochlorite, but hypo is very common word, and hypochlorite is used as a disinfecting chemical in the for water and disinfection. In addition, the chlorinated lime can also be used for disinfection. So, this is there. Now, when chlorine is added to the water, a mixture of hypochlorous acid and hydrochloric acid get formed via this reaction. So, you can see the chlorine, if gas is present, so it will react with water and we have hypochloride which is getting hypochlorous acid as well as hydrochloric acid which are getting formed. Now, this reaction is reversible as well, and this reaction is pH dependent and essentially complete within a few milliseconds. So, this will happen, so this will be dependent upon the pH also, and thus the type of chlorinated compound which is present in the water will depend upon the pH also. Now, the pH dependence of this chlorine can be summarized here. For the sake of easiness, I am just showing you a graph here, and we will try to understand this graph via the text which is given here in these slides. So, you can see here, if chlorine is present, so chlorine if it is added, so it can be in three different forms. So, Cl2, HOCl and ClO, and whether which type of chlorine is present, if it is pure water, then it will depend upon the pH which is shown here. So, we can see here that beyond 10 pH, okay, if chlorine is added, it will be in the negative form, okay. And if it is between around 6 pH to 3 pH, everything will be in the hypochlorous acid HOCl form, and below like 2 pH or less or 3 pH or less, some amount of chlorine will also be present. So, everything will get converted into some amount of that will get converted into chlorine also along with HOCl. So, if pH is less. Now, we will try to understand this more. So, in dilute solution and at pH levels above 1, the equilibrium is displaced to the right in this particular equation, and very little CH2 exists in the solution. So, some amount of Cl2 will be present if the pH goes beyond 1, and after 3 it will totally change. So, hypochlorous acid HOCl is a weak acid and it will dissociate poorly at levels of pH below about 6. So, it will not dissociate. So, that means everything will be in the HOCl form. Okay. So, hypochlorous acid between pH 6 and 8.5, there occurs a very sharp change from undissociated HOCl to almost complete dissociation. So, between 6 to 8.5, HOCl will dissociate into H plus and OCl minus, and in fact beyond 10 it will be complete dissociation that will happen, and because of that everything will be present in the OCl minus form. So, this is there. So, chlorine exists predominantly as HOCl at pH levels between 4 to 6. So, everything will be in the HOCl form between 4 to 6. Below pH 1, depending upon the chloride concentration, HOCl will get converted into Cl2. So, this is there. So, these are the different forms in which the chlorine will be present in the water under various condition, and this diagram, it is called as speciation diagram of chlorine species, and this is pH dependent. So, from this we can understand that also in between some, like suppose we have to find out at 7. So, we can tentatively know that okay, at 7.5 tentatively 50% of the chlorine will be in the HOCl form and 50% will be in the ClO minus form. So, this is the water chemistry with respect to chlorine that we can understand. At 20 degree centigrade and above 7.5 and at 0 degree centigrade above about pH 7.8, HOCl will always be hypochlorite ions will be present. So, OCl minus hypochlorite ions will be totally be present. So, if the pH is above 8, everything will be in the chlorite, hypochlorite ions will only be present, chlorine will get converted into hypochlorite ions. So, this is there. Now, chlorine exists in the form of HOCl or OCl minus, that will be considered as free available chlorine or free chlorine. So, we always want the how much amount of free chlorine is available. Also, the HOCl and OCl minus have different reactivity or oxidizing potential. So, depending upon their potential, they are able to disinfect the pathogens which are present in the water. So, this is there. Now, going further, the hypochlorite salts, if we are adding like NaOCl or CaOCl2. So, whether we are using sodium hypochlorite or calcium hypochlorite. So, they will dissociate in the water to yield different hypochlorite ions. So, they dissociate in this manner, we can see here. The hypochlorite ions, if they are getting added in the water, so they will establish an equilibrium depending upon pH, whether they will get converted into HOCl. So, some amount of that will get converted into HOCl depending upon pH. So, if pH is high beyond 8 or 9, so OCl which has been formed here, it will remain as such, but suppose pH becomes 6. So, some part of that will get converted into HOCl. So, this is there. So, the same active chlorine species HOCl and OCl minus and equilibrium are established in water regardless of whether elemental chlorine or hypochlorites are used. So, this is there. So, and these are the most common used chemicals for disinfection in any water tanks or otherwise. So, they are very commonly used. Now, the significant difference is the resultant pH, and it influences on the relative amount of HOCl and OCl minus which are present at the equilibrium. So, that already we have discussed. The elemental chlorine tends to decrease pH. So, each milligram of chlorine added reduces the alkalinity by up to 1.4 milligram per liter as CaCO3. So, this is very important information, and from this there will always be a pH decrease when we use elemental chlorine. Hypochlorites, if on the other hand we are using, and so always they contain certain excess alkali to enhance their stability, and they tend to raise the pH somewhat. So, this is there. To optimize the disinfecting action, the design pH is generally in the range of 6.5 to 7.5. So, in this range we generally get very good disinfection, and we are able to disinfect most of the pathogens out of the water if we are using chlorine as an disinfecting agent. Now, we will try to today understand some of the questions related to disinfection. So, the first question is given here for better understanding. So, a potable water is disinfected by 10 milligram per liter of HOCl and the final measured pH is 6. So, we have to find out that what percentage of HOCl is not dissociated. So, this is there, and the pK value of this particular dissociation reaction which is given here, it is 7.54 at 25 degrees centigrade. So, from the literature we can find out the pK value. So, the pK value of this particular equation is 7.54 which is available from the literature. We can find out experimentally also, there are many techniques for that. So, this is there. So, this is already reported. So, we have to find out that how much amount of HOCl will not dissociate if we are adding this HOCl at 10 milligram per liter at pH 6. So, this is the question that has been asked. Now, going further, if now since pK value is 7.54, so we can find out the equilibrium constant for this particular equation as K is equal to 10 raised to minus 7.54, because this is log minus log 10 K A. If we assume this to be this is to be K A. So, this will be equal to 7.54. So, thus we can say that okay, K is equal to 10 raised to minus 7.54. So, this value will be 2.88 into 10 raised to minus 8 if you solve it. Now, since the value is known, now equilibrium constant expression for this particular equation which is given here is like K is equal to H plus OCl minus divided by concentration of HOCl. So, these are the respective molar concentrations which are there. Now, this is already Ka value already we have found. So, this is written here. Now, it is the pH has been given. Now, the pH is 6. So, since the pH is 6, so that means the pH is equal to 6. So, that means minus log H plus concentration is equal to 6. So, that means the H plus concentration we can find out, and this is equal to 10 raised to minus 6. So, this is there. So, this is what is written here 10 raised to minus 6. HOCl concentration we have to find out, and the relationship between both is now known. Now, the total mass conservation law tells us that HOCl plus OCl minus, they should be equal to 100% of the total HOCl which has been added into the solution, and which is 10 milligram per liter in the present case. So, from that data what we do is that we add this relationship here, and if you solve it, so 34.7 OCl minus plus this is equal to 100%, and if you solve it, we will be finding that okay, OCl concentration is now 2.8%. So, that means HOCl concentration is 97.16. So, through this we come to know that at pH 6, it is 97% of the chlorine or hypo added will be in the form of HOCl. So, this from this we get to know the different ideas which can be used for calculation of the concentration of different chlorine species from the data that we have. So, now in this lecture we have started the disinfection section, and today we learned regarding that what are the different types of disinfectant which are used, some chemistry part of the disinfection, and we tried to calculate that how much amount of chlorine and which amount of which type of chlorine species will be present at which pH. So, we perform some calculation of that. So, we will continue with the disinfection section in the next lecture onwards. Thank you very much.